Hey guys, let's take a look at algebraic methods. So quite a bit on this video. We go over a degree of expression, coefficients, combine like terms, plugging in values, a word problem, multiplying exponents, solve for A in terms of B, and then factoring. So that's quite a bit, but this exam does kind of go all over the place, and so that's what we got to do. All right, so let's jump right into it. So first we'll do a degree of expression. And that's with this first equation up here. This guy is going to be the degree of expression question. And so when you're asked for a degree of expression, it's just the sum of all the exponents in a monomial. Okay, so the exponents we have here are 2, 5. Here, if we don't see anything next to a variable, that means there's a 1. And we only care about the stuff next to the variables, right? So we have 2 plus 5 is 7 plus 1 is 8. Degrees of expression, 8 for that monomial. Okay, and that's all you got to know how to do. All right, pretty straightforward. Certainly not challenging from like a math standpoint, just knowing what to do with it. And then next we have coefficient, right? So we're going to look at the coefficient for this guy, right? And with coefficient, so a coefficient is just the number in front of the variable. Okay, so here we have 4 is in front of this variable, 5 is in front of the y, and then again with z, we don't have anything, and so that means it's a 1. Right? And then we just add them up. 4 plus 5 is 9, plus 1 is 10. That is the coefficient. Okay, that's all you got to know, right? Nothing too difficult there, right? Just knowing the rules and making sure that you don't get them twisted, right? So remembering that, for degrees of expression, it's the exponent. For coefficient, it's the number in front of the variable. If you know that, you got it. Okay. That wasn't too bad. Right. What's next? Combine like terms. All right, you gotta give me a second to write this out. 2x squared. So when we're combining like terms, what that really means is like, so there you had then the 2x squared. So all of the x squareds are going to combine together. Here we have 3x to the third. All the x to the third are going to combine together, plus 5. Right? All the regular numbers that don't have a variable, combine those together. And we got a minus sign here. And then we got 3x squared plus x plus 7. Sorry about the handwriting. Okay, so usually we start with the one that has the highest number next to the variable, right? And so that one would be this 3x to the third right here. Okay, so I don't see any other x to the thirds in any part of this expression, right? So we'll put that just down here by itself. 3x to the third, and when we're done with it, we just cross her out. Okay, and then next, how about x squareds? So here's a 2x squared. Don't forget when we're going over, and there's a 3x squared here. And then don't forget about this minus sign, right? So people just see the 2 and then they just add them together and then the answer gets all crazy on us. 2x squared minus 3x squared negative x squared. Okay, cross them out. We don't double count or anything by accident. Okay, kind of going down the list. Next we'll go with x, right? It's the only place we see that is right here. Because all that's left is a 5 and a 7. We'll combine those in a second. So we'll just say plus x. Looks good. Cross you out. And then all that's left is 5. And remember, don't forget that minus sign. 5 minus 7. So 5 minus 7 is negative 2. There's our answer. Okay, so that's combining like terms. This is exactly what it sounds like. just combining the similar exponents and then having a new expression when we're done. Sometimes people rush through those a little too much, and miss out on the minus sign or something and accidentally add something when they should have subtracted. Besides that, there's really no reason to get that kind of question wrong. It's pretty straightforward. Okay, plug in is next. Again, you're going to have to give me a sec here. Write all these things out. All right, so we got x plus 1 squared plus y squared minus 4. All right, and then they're going to, in a sec here, give us like x equals something, y equals something. So you're looking at these plug-in problems. PEMDAS shows up quite a bit. We'll see what happens. Unless you remember PEMDAS, like parentheses, exponents, multiply, divide, add, subtract. Right? So that's the order in which we're supposed to solve these. Okay, so we have x equals -2, y equals 3. Okay, and then we plug in. And already you can see that there's exponents here, there's a subtract thing, there's a parentheses. PEMDAS is going to come into play. All right, so we got -2 plus 1 squared plus, so we said y is 3, so 3 squared. And minus 4 will carry on down. Okay, so now PEMDAS. Parentheses first, right? So that's a 1 squared. Okay, there's no other parentheses. Exponents are second in PEMDAS. 3 squared is 9. And still just saying subtract 4. Okay. So parentheses first, exponents. So really, just erase this. So 1 squared just becomes 1, right? Okay, so now we've done parentheses, we've done exponents. There's nothing here to multiply, nothing to divide. Add first, then subtract. Okay, so 1 plus 9 is 10. 10 minus 4 is 6. There's our answer, 6. So nothing too hard. You just, plug the numbers into the equation and then remember PEMDAS. Go ahead and solve. Pretty straightforward. So all this stuff that shows up quite a bit on the test, all of it really, and none of it really like complicated math or complicated reasoning. Few of them you just have to know what to do, like with degree of expression and coefficients, you just have to know what they mean, what they're asking you to do. As long as you know that, I think you get it right. Okay, word problems. So most common word problem is distance equals rate times time. Okay, and then they're going to give you almost always 2 of the 3, and then you have to solve for the third part. Okay, so let's read through this and kind of like write it out as we're reading the word problem. So it says Julie has driven, Julie has driven 150 miles in 3.5 hours. Okay, so already we got some info there, right? 150 miles, that's distance. I like to write it out just like as I'm reading this thing. And it said in 3.5 hours, right? So that's time. That's not much of a decimal. There we go. 150 miles, 3.5 hours. If she drives 100 miles in the next hour and a half, what will be her overall speed in miles per hour for the entire trip? Okay, so miles per hour is a rate. Okay, so that's what we're going to end up solving for is rate. Okay, so it's a distance. We went 150 miles, and now she's going to go 100 miles more in the next hour and a half, right? That's the question. Okay, so let's go ahead and say there's another 100. Tack on there. 150 plus 100. We'll call that 250. And it was 3.5. and then she was going to drive another hour and a half, 100 miles. Okay, 3.5 plus 1.5 is 5. Okay, now we have everything we need to set up our equation, right? So we'll go back to our distance equals rate times time. Distance is 250, right? Rate, which is the miles per hour that they're looking for, we don't know. Time, total was 5 hours. Okay, now we got all we need to know. Okay, so then we just divide each side by 5 and get rate by itself. And 250 divided by 5, it's just a plain old 50 miles an hour. Right there. That's all you got to do. So that's going to be the setup. So in this one, they threw, one extra little trick in there by starting off with 150 in the 3.5 hours and then adding the 100 miles in another hour and a half. So you just add them together. Pretty simple. And then go solve. Okay. That again is a really common word problem. Got to know distance equals rate times time. A lot more examples in the app on this. All right, so if you feel like you need some more practice, word problems in the WhipSmart app. Okay, moving right along, multiplying exponents. Okay, let's write this one out again. So your rule to remember on multiplying exponents is when we're multiplying exponents, we add them. So we'll do this here in a second. All right, but if you multiplied them or something like that, then probably not getting the right answer. Can't think of any way you'd get the right answer. As long as we add them, the math here is, not hard at all. Okay. So it's 3 a to the third b to the fourth times 6 ab squared. Okay, so 3 times 6 is 18. Okay, and then again, we're going to add exponents, right? Okay, so here where there was just an a and a to the first are the same. So that's one little thing you're being tested on, right? So we have a 3 and a 1. 3 plus 1 is 4, right? So there's a to the fourth. And then we got b to the fourth, b squared. 4 plus 2 is 6. There's our answer. You might have thought it was harder than that, but that's really all there is to it, right? We multiply the coefficients together. Remember that term from more like the beginning of this video? 3 times 6 is 18. Add the exponents. If you see nothing, put a 1 up there next to the variable. That's all you got to know. There you go, multiplying exponents. Common question as well. All these in this video try to pick out like the most common types of questions that you can see in this section on algebraic methods. Okay, solve for a in terms of b. This maybe is the hardest one in this video. Okay, so what you'll see is you need to plug in and substitute values that you are given for the question. So in this one, we were given actually 3 variables, a, b, and c. So we'll write these out. So a equals 1/2 b and 3c equals b. And then they want you solve for c in terms of a. So that's kind of weird language, solve for c in terms of a. So it's going to say like, c equals some fraction a. That's what your answer is going to be. Okay, so how do we do this? Right, so we start off, so we just somehow need to substitute, right? So if we can get a equals 1/2 b, right, and we need to substitute this b in here. So what we'll do is if we multiplied on this equation here at the top, we multiplied each side by 2, and we could get 2a equals b. Okay, and then we can substitute that in right there. Okay, so 3c equals b is, now we know that's the same as saying 3c equals 2a, right? Because 2a equals b. It's the same thing. Okay, and then from here, solving is pretty simple, right? Because we said they asked for c in terms of a. So c equals some fraction a. All right, divide each side by 3, so we can get c by itself. C equals 2/3 a. There we go, right there. So sometimes when you watch somebody else do it, it looks pretty simple, and then you see it, and then kind of being able to think it out in the way that I just did can be a little bit more complicated. So, like all these types of questions, lots of examples in the app to go through that can help you out. But you will see this type of question, and this one might take a little more practice than some of the other stuff that we've done so far here in this video. Alrighty, it was A in terms of B, and it actually ended up being C in terms of A in this one, but one more, and this is factoring. So this is something else that most likely you did in high school, and not too hard to imagine that we could have forgot how to do it because we haven't done it in several years. So we'll go x squared plus 15 equals 12x minus 20. And you're solving for x. What do we do with this? Okay, so the way you go about doing this is you need to get everything onto the left side of the equation and have it equal 0. That's our first step. And then we factor from there. So 12x minus 12x is 0. So we'll do that to both sides. And negative 20 plus 20, 0. We'll do that to both sides. Okay, so now we're going to have 0 over there on the right side. And okay, so right, 12x minus 12x, that's nothing. Negative 20 plus 20, that's nothing. Okay, what do we got over here? We got an x squared, just combine like terms. Remember doing that a few minutes ago? Minus 12x, there's no other x's, so just minus 12x, plus 15 plus 20 is 35. Equals nothing. Okay, so from here, what we're doing is setting up something like this. Equals 0. Okay, and so we have x squared, so we're going to have an x here and an x here. Okay, now what's going to go next to them, so it'll be x plus something or x minus something, is the numbers, these two numbers, like there'll be a number here and there'll be a number here, okay, have to multiply to 35 and add up to negative 12. Okay, so if we're thinking about factors of 35, right, there's 1 in 35, right? So if it was x plus 1 times x plus 35, that adds up to 36. So it does multiply to 35, but it doesn't add up to negative 12, so that doesn't work. Negative 1 and negative 35, right? If you had two negatives, that makes for positive 35. That's not going to work either. But then we look at 5 and 7. Like 5 times 7 is 35, but 5 plus 7 is 12. We got that 12, right? What about negative 5 and negative 7? Negative 5 times negative 7, that's 35. Negative 5 minus 7, that's negative 12. That's what we wanted. Okay. That's how you go about it. There's your minus 5. There's your minus 7. Okay, and we're almost done. Okay, and so the solution was 0, right? This is 0 right here. Okay, so now we have x minus 5 times x minus 7 equals 0. Okay, and then what we're looking for is, like, what number for x will make this first thing 0? What number for x will make the second thing in the parentheses 0, right? And so if we have x equal 5, 5 minus 5 is 0, and that's going to make the solution 0. Okay, so that's a good answer. And if x equals 7, that also will work, right? Because if I put 7 in right here, then 7 minus 7 is 0. Bam. X equals 5, x equals 7. That's the solution, right? Either of those will work. And then if you want, you can go ahead and plug it back into the equation at the top just to make sure that you got it right. But either of those will work out just fine. Okay, that is algebraic methods.